Now we will study how Thevenin theorem can be used in the network analysis. For that I will consider the simplest example, and the simplest example is and this is the illustration of the theorem. Illustration. Consider a network. Suppose we have this network which I already discussed before. This is the voltage source, here this is the positive terminal and this is the negative terminal, and we have three resistors connected in this way, and here we have the two terminals, terminal A and B. This is terminal A and this is terminal B, and we have the load resistance across this terminal. This is the load resistance, and this is the resistance R1, resistor R1, this is resistor R2, and this is resistor R3. Now consider a network in figure. So if this is figure 1, then this will be figure 2, and this will be my figure 2, so this will be figure 3. Given in this figure 3. Let us calculate the current IL, the load current through the load resistance, load resistance RL by using Thevenin theorem. This is our task. We have to calculate the the current IL, the load current through the load resistance by using Thevenin theorem. Now we will use two steps to solve this problem. The step number 1 is we have to calculation of Thevenin voltage. Once we calculate the Thevenin voltage, then we have to calculate the equivalent resistance or Thevenin resistance. Then we will connect the Thevenin voltage in series with the Thevenin resistance, and then we have to calculate the load current very easily. This is IL. First we have to convert this figure to this form. So for that we have to calculate the Thevenin voltage, and we know that Thevenin voltage is the open circuit voltage between terminal A and B. It is the open voltage between terminal A and B. So it means that this figure 3 can be reduced to this one. So we have this open circuit. Now we remove the load resistance. This is terminal A, this is terminal B. Across this terminal we will calculate the voltage, which we will call Thevenin voltage. This is the source voltage Vs. This is positive, this is negative. Now this is resistor R1, this is R2, and this is R3. Now this is positive, so this will be positive, this will be negative, this will be positive, this will be negative. Similarly, this will be positive and this will be negative. Now we reduce figure 3 to figure 4. I call it figure 4 by removing the load resistance RL it is now open circuit. Because this is open circuit, the two ends are not connected with each other. Now how we can calculate Thevenin voltage now? How we can calculate Thevenin voltage? Now the voltage source, this voltage source produce current, and that current flowing through R1. Suppose this voltage source produce current I. Let's suppose this current first flow through R1 and then through R3. Because the current cannot flow through R2 because this terminal is open. So there is no voltage drop across this resistor R2 or this resistance R2. If there is voltage drop across this resistor R2, then the voltage, this Thevenin voltage will be the voltage drop. Now there is no voltage drop across this resistor R2, so the voltage drop or the Thevenin voltage will be the voltage drop across this R3. So we have to calculate the voltage drop this across this resistor R3. That will be the voltage drop across terminal A and B, because there is no voltage drop across this resistance R2, because no current is flowing through this one, because this in is open. So the current is flowing in this way, so the Thevenin voltage will be basically the voltage drop across this resistor. Now the voltage drop across R3 is using Ohm's law, very simple. We know the Ohm's law is V is equal to IR. Now the voltage drop across R3, I represented by V3, which is equal to current flowing through this resistor, which is I times the resistance R3. And this voltage drop is basically what? It is this Thevenin voltage. So it means that V Thevenin voltage will be equal to I R3. Now our task is to calculate I. I can write it clearly. Thevenin voltage is equal to I R3. Now I have to calculate the current I, and for that I will use the Kirchhoff law, because the current is flowing in this way, so I will apply the Kirchhoff law in this one. Now apply Kirchhoff law. We start from this point. We are moving in this way, and this way, and in this way, and goes back to this way, like to this mesh. We have this mesh. Across this there is no current, so the current is always going in this way. Now apply Kirchhoff voltage law to the mesh shown above. Now look at here, we are moving from minus to plus, from lower to higher, so Vs will be positive. Then we will reach to this point. Here we are moving from higher to lower, like from positive to negative. So the voltage drop across this one is I. Current is flowing through this resistance is I, and the resistance is R1. So it will be minus I R1. And then we will move here. There is no current flowing, so the current is only flowing in this way. Here again we are moving from positive to negative, higher to lower. So this will be minus I R3 is equal to 0. So we get from this we can get I very easily if we calculate I, which is equal to Vs. Bring this factor to this side and taking I common, So we have R1 plus R3 which goes to the denominator. This is the current. If this is equation 1, this is equation 2. Okay. Now put equation 2 in 1. We have Thevenin voltage will be equal to Is Vs over R1 plus R3 times R3. This is the Thevenin voltage. So the process is very simple. First we have to calculate the Thevenin voltage. For the Thevenin voltage we will use the open circuit. Like we have to remove this load resistance. So here we remove the load resistance. This is now open circuit now. Now this source voltage source produce current I which is flowing through R1 and then through R3 because there is no current flowing through this R2 because this terminal is open. So if there is no current flowing through R2, there will be no voltage drop across R2. So it means that the voltage drop across point A and B will be equal to the voltage drop across this resistor R3. So we have to calculate the voltage drop across this resistor. That will be this Thevenin voltage. So voltage drop the voltage drop across R3 is, which is according to Ohm's law, V3, which is equal to current flowing through the resistor, which is I, times the resistance, which is R3. Now this will be the Thevenin voltage. Now in this voltage, in this Thevenin voltage, we have the current which is unknown. We have to calculate the current. Now the current can be calculated by using the Kirchhoff law to this loop, because current is moving from positive to negative. So once we apply Kirchhoff law, we get the current. Putting this with the value of this current here, we get the Thevenin voltage. Now our next task is to calculate the Thevenin resistance. So we have to calculate the Thevenin resistance, which I will do. I think it's better to do in the next video. Yes, I think it's better to do in the next video.